In this video, we're going to continue with some Ka and weak acid calculations. So we're just going to do some extra practice problems. Let's say you were asked to calculate Ka if the pH of a 0.25 molar bromic acid solution was found to be 4.65. Let's say you weren't given a reaction. You should be able to write the reaction based on what we know about acids. Acids don't need a proton. So let's pull off a proton. If I lose a hydrogen, BRO. If this is neutral and I lose a proton, charge would be -1. So I have the initial concentration of my acid, 0.25. Assume the products are always going to be 0. Reactants decrease in concentration, products increase in concentration. All right, so I know at equilibrium, the concentration of H plus is equal to X. So if I can solve for the concentration of if I can solve for the concentration of H plus, I know what X is going to be. The concentration of H plus is equal to 10 to the negative pH. My pH is 4.65. 10 to the negative 4.65. Gives me about 2.2 times 10 to the negative 5th. So this is equal to the concentration of H. The concentration of H plus is also equal to X. So this is equal to X. BRO minus is equal to X. So its concentration is also 2.2 times 10 to the negative 5th. We know at equilibrium the concentration of bromic acid is 0.25 minus X. Again, let's assume that X is negligible. So now I have all of my equilibrium concentrations. I want to solve for Ka. So let's write my Ka expression and solve. Ka is equal to products over reactants, each raised to the power equal to their coefficient. Let's plug in what I know. and solve for Ka. (1.9 times 10 to the negative 9th is my Ka value. So notice that we dropped the X. At equilibrium, the concentration of bromic acid is 0.25 minus X, but we dropped that X. Again, we're assuming X is negligible. If you want to make sure, was that the right thing to do? Should I have dropped X? We can take X over the concentration of the weak acid and multiply by 100. If our answer is less than 5, it was okay to drop it. So we figured out that X was 2.2 times 10 to the negative 5th over the concentration of my weak acid. Let's figure out what that percent is. Super small. 0.0088%. Since it's less than 5, it's okay that we dropped X. Let's look at what happens if we didn't drop X. 0.25 minus X. Is there much difference between 0.25 and 0.249978? No, those numbers are so small. Since they're so small, it's not going to make much of a difference. So again, we could drop X, assume X is negligible, if X divided by the concentration of the weak acid times 100 is less than 5%. Let's try another one. Calculate Ka of a 0.20 molar solution of propionic acid, CH3, CH2, CO2H. With a pH of 4.88. So again, I'm not going to give you the reaction, but I think you should be able to do it. This is an acid. Acids are going to donate a proton. So let's pull off a proton. My acid is neutral. If I lose a proton, it now has a charge of -1. Let's fill out what we know. The initial concentration of the acid is 0.2. Initial concentration of products are always 0. Reactants decrease in concentration. Products increase in concentration. I'm going to write that X for now, but it's probably going to be negligible, so we could just ignore it. All right, so we need to solve for X. We're going to start by using pH to calculate the hydrogen ion concentration. The concentration of H plus is equal to 10 to the negative pH. 10 to the negative 4.88. about 1.3, 1.32 times 10 to the negative fifth. So this is the concentration of H+, but at equilibrium, the concentration of H+ is equal to X. At equilibrium, concentration is equal to X. X is 1.32 times 10 to the negative fifth. Propionic acid. At equilibrium, 0.20 minus X. Let's assume X is negligible, so 0.20. So if we want to solve for Ka, I need to write my Ka expression, and I can plug in all of my concentrations. Ka is equal to products over reactants, each raised to the power equal to their coefficient. In this case, all of my coefficients are 1. I already circled all of my concentrations, so let's plug those in. .7 times 10 to the negative 10th. Again, no units for Ka. If you want to check your 5% rule, X over the concentration of the weak acid. .0066%, way under 5%. That means X would not make much of a difference in calculating our Ka value. So for these two problems, we calculated Ka. Let's do a problem where you have to calculate pH. This will probably be the last one. Last example. The Ka of benzoic acid, C6H5COOH, is 6.3 times 10 to the negative 5. Calculate pH. If the concentration is 0.35 molar. So first step, let's pull off a proton. write out our reaction. Let's fill out what we know. My initial concentration is 0.35. Always assume products to be 0. Concentration of the reactants decrease, so minus X. Concentration of the products increase, plus X. All right, let's write our Ka expression. So Ka is equal to products over reactants. And now we can plug in what we know. So we were told that our Ka is 6.3 times 10 to the negative fifth. This is an equilibrium expression, so you want to look at our equilibrium row. X times X gives me X squared. I'm going to assume X is negligible, so the concentration of benzoic acid, I'm just going to put in 0.35. And now let's solve for X. So let's start by multiplying both sides by 0.35. This gives me 2.205 times 10 to the negative fifth equals X squared. To solve for X, next we need to take the square root of each side. And I get 4.7 times 10 to the negative third equal to X. We want to calculate pH. pH is equal to the negative log of H+. So if I want to calculate pH, I need the concentration of H+. Well, at equilibrium, the concentration of H+ is equal to X. So this value is equal to X, but it's also equal to H+. So now let's solve for pH. pH is equal to the negative log of 4.7 times 10 to the negative third. Negative log of 4.7 times 10 to the negative third. My pH is about 2.33. Again, for this class, we're always just going to assume that X is negligible, but if you want to be sure, you don't want to take the shortcut, X divided by the concentration of the weak acid. If it's less than 5%, it's okay to drop X. X was 4.7 times 10 to the negative third. My concentration was 0.35. About 1.3%. It's less than 5, so it's safe to drop X. If you did this calculation and your number was greater than 5%, then we would have to include X, and then the math becomes much more messy.